everyone and welcome to Unit 43, More Trigonometry. We are going to look at Lesson 4 where we're going to calculate area of non-right angled triangles. Hope you are keeping well and safe, and fingers crossed we get through this topic well. Okay, let's see how it fits in. So far we've looked at graphs of various functions, sine, cos and tan. We've looked at the sine rule, we've looked at the cosine rule. What we're going to do now is look at this area bit, and then we've got a couple of bits left over. We've got a bit of transformation of trig graphs that we might do on a video, we might do that when we get back to school. And we've got a little bit of 3D Pythagoras, which sounds hard but it's dead easy. Okay, let's crack on with this. So if we were going to calculate the area of this triangle, from Formula Fridays and from doing our formula quizzes, you'll remember that to work out the area of a triangle, we need to do a half times the base times the height. Now the problem that we've got here is that we don't actually know what the height is. Okay, so the fact that we don't know the height causes us some problem. However, there is a workaround for this, and it's using a new formula. So you'll remember the notation in terms of how we set up our letters. We've done this for sine rule, we've done it for cosine rule. Little letter for the length, capital letter for the angle, and they've got to be opposite each other. It's exactly the same when we are looking at the area of a triangle. Obviously we've got half base times height, but actually what we can do is use some of our trig knowledge to calculate what this height is. So let's see how we do it. Now if we were to drop a perpendicular down here, you can see that this is the height of the triangle. It makes a right angled triangle. This is our height, and using a little bit of our normal SOHCAHTOA knowledge, we know that sine is opposite over hypotenuse. So sine of this angle here is opposite over hypotenuse. So the height is A sine C. So just moving the A up here. Now if we know that that's the case, then we can say that the area of a triangle is a half times the base times A sine C, or just to tidy it up a little bit, half AB sine C. And you'll see from the lesson title that I've just called it half AB sine C. It's quite common for us to talk about area of a triangle in these terms. So two different ways of doing your area of a triangle. You've got your normal way, half times base times height, and this new way, half AB sine C. Should we see it in practice? So I've put this a little bit up here on it as well. I mean, fundamentally, I only ever remember half AB sine C, but depending on which angle you've got, really all you need is the angle, and you need the other two sides that are next to it. So typically we talk about this one. So notice if this is your angle, you need B and you need C. But if this was your angle, let's do it as a straight line, then you need A and C. So you just need an angle with two sides either side of it. Same here with angle B. Sorry, I've just done angle B. Same here with angle C. So if you've got angle C, you need A and B. Angle A, you need B and C, and so on and so on and so on. Okay, so fundamentally this is the one that we're going to use. I tend to just relabel my triangles. It's just easier that way. Let's have a look at this one then as an example. So for this particular question, we've got an angle. We've got the two sides either side of the angle. We can plug this straight into our formula. So area is a half AB sine C. So AB sine C. Type it in our calculator and we're going to get an answer. It's as easy as that. So this is quite a nice activity to do, quite a nice topic to learn. You need to learn a formula, you need to put some numbers in. This one, again, you've got a length, you've got an angle between them, so we can just type it in. If you want to have a go at this one now, feel free to do so, otherwise just watch the video. So we're typing in the formula, half AB sine C. Again, which one's A and which one's B is kind of irrelevant as long as the angle is in between the two. And there we get our answer. Sometimes, I guess, the bit that makes it a little bit more tricky is sometimes we're given the area, but we're asked to either find an angle or a side, but we can do exactly the same thing. So we've got in a triangle ABC, A is this, B is this length, and the area is 5. Find the angle BCA. So remember, it's the middle letter is the angle. So this is angle C. So we've got A, B, sine C. So we just set it up as normal. If it's tricky, obviously you can draw a picky, that sometimes helps. But let's draw it out. Here we've got a side, we've got the missing angle. We know that the area is 5. So 5 is half AB sine C. These are all numbers. So we can times all that. All these numbers here we can then divide across the other side. So 5 divided by this gives us sine C. And then using our normal trigonometry knowledge, we know that if we want the angle, we have to undo the sine. So sine to the -1 of this will give us our angle. If you're making notes, feel free to sort of kind of pause the video at this point, make some notes as we go, and then we'll look at another example. Okay, and in this triangle, again, we'll be told what the area is. We're being asked to find the length of the side C. So again, it's the one over here. We've got these enclosed sides. Again, we need this length, we need this length, we need this angle to work out the area. We've got the area. We now need to work out what this side is. So we type it in. So 100 is a half AB sine C. Half AB. Now it doesn't really matter that I've said AB. I know this is side C. I'm not going to get worried about the other things. I just know it's the enclosed bit that I'm looking for. So we'll just type it in. Again, number, number. This on a calculator is a number. So you can do 100 and you'll end up dividing it by that times that times that. And you get your length, 16.84. Okay, hopefully you've taken some notes on these. Bear in mind that when you start to do some exam questions on this, you might have to combine this fact, area of non-right angled triangles, with sine rule, with cosine rule. But for now, all I'm really bothered about is that you've understood how to do this area of a triangle sorts of questions. On class charts there is a worksheet. The worksheet's got a few questions on working out the area and a couple of questions where you have to work out either the missing side or the missing angle. So pause the video, have a go at the worksheet, solutions will pop up next. And then if you're happy and you want to do an extension question, here's an extension question for you to try. So this is a quadrilateral. So we've got use the measurements given to find the area of this quadrilateral, give your answer to 3 significant figures. We've only talked about area of non-right angled triangles. So as a clue, what I would suggest that you do here is you split this down here and you make 2 triangles, and you can just add them together then. Okay, so if you want an extension question, give this one a go. And then, like I say, solutions to the worksheet are here. Tick them off, see how you get on. Any problems, obviously get in touch like you have been doing. But fingers crossed you've done well on this topic. It's not a particularly difficult one. Again, once you've learnt your formula, you're putting numbers into it. Okay, so fingers crossed we've done well. Now, what I have done is set a bit of extra work on Dr. Frost Maths for students. So if you're happy to do that and you've done your worksheet first, if you've done your worksheet and you've got it right, by all means do some work on Dr. Frost as well. If you're getting stuck on your worksheet, please contact me, email me and let me know what it is that you're stuck on and I'll see if I can help you in one way or another. Otherwise, look after yourself and I will see you all soon. Bye!